I'm the manager of information technology at Connacher Oil and Gas. Not anywhere near the size of Peter and Eric's companies, but we do face some similar challenges. Just to give you a bit of a perspective, we only have 300 staff in comparison. So, before I get started, how many of you have heard of SAGD? Just show of hands. Some people in the back. Okay, so a good number. I won't spend too much time on introducing it, but I did want to let you know a bit about the process. So we'll start a bit on that. Before I do that, though, I'll just introduce Connacher. Connacher is a publicly traded company on the Toronto Stock Exchange. We have an integrated strategy, which means that we have production in a number of different areas. So we have our primary asset is the 100% interest in about 500 million barrels equivalent of proven and probable reserves of bitumen or oil sands at our Great Divide site, which is in the northeast of Alberta in Canada, near Fort McMurray. We have two 10,000 barrels a day rated steam-assisted gravity drainage plants. That's oil sands plants. We have about we have a 9,500 barrel a day rated heavy oil refinery down in Great Falls in Montana. And we also have some conventional oil and gas operations in Alberta, a bit in Saskatchewan. And what the integrated strategy provides for us is this idea of a product notional hedge. So when the differential for end products becomes a little bit smaller, we have less profit at the refinery. Hopefully that means at the same time that we're making more money on the bitumen side or on the conventional oil side, and vice versa, of course. So we've hedged our risks a little bit in terms of our product that way. So steam-assisted gravity drainage is a oil production process that allows you to get oil sands, produce oil sands in situ, which means out of the ground in place, similar to how most conventional oil is produced. However, it's more complicated than that because bitumen is very, very thick, about the consistency of peanut butter. And try sucking peanut butter through a straw, you'll know how hard it is to try to produce that. So what that means is you have to heat it up. You have to pressurize the reservoir so that you can lower the viscosity of the bitumen. So what we do is we extract water, and actually at Connacher, all the water that we use is non-potable. So a little bit less of an environmental impact there. We're not taking surface water for any of the injection processes. We're not using fresh water, which is a bit of a contentious issue in the oil sands production. And then you boil that water. We just burn methane, natural gas, just a very clean way of getting energy, very efficient. Boil that water, inject that steam into an upper well. You can see here, I don't think I can show you one here. Oh, there's a laser pointer. You can kind of see here. There's an upper well where we inject steam. That heats the chamber, and the heated oil is assisted by gravity down to the lower producer well, where we have an electronic submersible pump, typically, that pumps upwards, and then also a pump at the wellhead, which pulls oil out. Bitumen, not oil yet. Once you have that bitumen out, what do you have to do with it? Well, that's actually where the bulk of the complexity of our processes exist, or above the surface. We have, first of all, you have to separate the bitumen from the water, the oil sands from the water. And that's a relatively crude process because there's still quite a bit of oil left in that water. Once you have that bitumen out, you dilute it because it's still quite thick. How are you going to get it to market? It needs to be thin enough to actually put into a truck or into a pipeline. So we have to dilute it. So you use lighter oils to do that, which is a cost. And you can store it in your storage tanks, and then you transport it. For Connacher, we don't have a pipeline right out of our facilities yet. We don't have enough production to make it viable. It's coming, but we're not there yet. So everything is trucked. So once you have your oily water separated out, you now need to de-oil that water and treat it, because it's full of minerals, it's full of oil, and you can't just turn around and reuse that. Well, technically, I guess you could just throw it away, but because you're producing far more steam than you are oil, you need to, for economics, you do need to reuse your water. Also, we don't want to pollute the environment, right? So you treat that water and you send it back off to your boilers. So that's just a 101 on SAGD. Production objectives here are pretty simple. You want to produce as much bitumen as you can for low costs. And from a systems perspective, how can we do that? Well, we want to maximize the production, and in order to do that, you need to maintain high availability on those systems. That is really key here, because with SAGD production, you need to keep that reservoir nice and warm. It needs to be kept pressurized. So if your plant shuts down inadvertently for too long, you can damage your reservoir considerably, resulting in untold losses. It's almost impossible to calculate what the cost of a long outage would be based on what you lose out of ability to produce. So it's very, very important to maintain high availability. And then from the operational cost perspective, you want to make all this oil, but you want to do it at a very low cost if possible. So again, high availability plays a part here. Our steam to oil ratio is a very big indicator of how well we're doing for cost for each barrel that we produce. If you have to put in 10 barrels of steam to get 1 barrel of oil out, you're spending a lot of money on natural gas and processes to get that water down to the ground. And chances are you haven't built your plant to be able to produce that much water. So the other thing too is those electronic submersible pumps. They're by nature, with all the contracting and expansion due to heat, they're underground, and if you keep shutting those off and turning them on, they'll just quit. And it's really difficult to know how much an unplanned outage will affect their lifespan. But that's a huge cost, because it's about $1 million to put one of those down there. So if you're constantly shutting them down and having to plug those back in, then you're going to incur those costs pretty quickly. Another system, aside from high availability, another system's goal is to reduce your chemical use. If you have appropriate trending and data, you can reduce the costs associated with all the chemicals you use. You can find more effective chemicals or less expensive chemicals that do the same job, or almost as good of a job. And unless you have the information that tells you what happened last time you put in that chemical or how much you put in, you're not going to know. The other thing that we get out of these systems to lower costs is just the ability to provide effective controls, efficiently make changes, and understand what's going on in the plant. So we have a fairly complex process. I mean, inside this one process, we're not talking about the dozens or even hundreds of processes that Eric and Peter are talking about, but this process itself, this vertical, is fairly complex. We use Rockwell Automation's plant packs system, or at least currently portions of it. For the control automation itself, we use this factory talk view application for the HMI. It provides the real-time data and automation, but what we found in the past is that we didn't really have enough visibility for long term or from a reporting and trending perspective. So I'm not going to go into too much detail about this network architecture, but you can see at the top left, I've got a Calgary head office up there. I don't think I can see this, so I'll just point it out. So there's a Calgary head office, and near the top left in that red box, that has a connection to our data center. Then it connects to our Pod 1 plant. That connects over to our Algar plant. Everything in the red side is an IT side of the IT side of our network, traditional IT systems. Then you have this integration. I've blown out the control system side of the second plant, Algar. And that's what you see the whole rest of the graph. So you're trying to get information from this, in the top right there, for instance, well pad 202, from pump, I just have it generic pump 1, going to a PLC, going to a separate standalone HMI server, which it then connects back to our control center server room to an HMI there, which connects to a historian, which connects back through the firewall, back to our corporate network, travels 500 miles over a leased fiber circuit back to our data center. We're talking about getting real-time data across a fairly large distance here back to our end users. One other thing I wanted to point out on here is the IT, as I'm sure you're all aware, the IT systems are becoming more and more integrated with control systems. And in this case, in our case, a lot of the control systems operate on IT systems. And as we require more and more data coming out of these systems and integrating with our business, we see more demands to get more users seeing that data, faster response. It's not good enough to have somebody just write a manual report or summary. It should be tied in directly. But that, of course, incurs some security risks as well. So we have to be really aware of that when architecting these solutions. So we have some challenges with having multiple sites. We need to have centralized and harmonized reporting requirements, or we have those actually. Trends across sites. We want to see various information trended between the same equipment across two plants to see which one's working better. Sometimes it's different manufacturers. We want to know, do we want to go with that manufacturer in the future, or do we want to start, or do we want to stick with our old manufacturer? We need to integrate with other systems. Control systems isn't enough. When we're talking about collaborative production management, or I just call it production intelligence, really, you want to tie into any other system that you need to trend across or report against. You still need to maintain fully independent systems, though. The plant, in our case, we want our plants to operate independently, so if one shuts down, you can keep operating from the other one. It's pretty important. You don't want to lose 10,000 barrels a day of production because your other 10,000s are missing, right? And of course, again, security concerns have to be balanced against your accessibility. So in order to meet these challenges, we went with another part of the Plant Packs suite. It's called Vantage Point. And the advantages to that system are that one of the major advantages that it was able to integrate with our other existing systems. Terminal Boss is our truck ticketing system, which allows marketing and other groups to track where our oil's going and who we're selling it to, and when, and how much. And then we have our DART system, which is a third-party reporting tool, which also provides the ability to calculate calculate adjustments that are part of our regulatory environment and other adjustments that need to be done for accounting purposes. Because as Connacher is a fairly small player, we're actually price takers. We work off of whatever our buyers tell us we sold them. So we do have a metered value that's leaving our pipeline to the truck terminal. But at the end of the day, we have to rely on our buyers. They're the ones who tell us what we sold them. So But it's useful to know how much they're gouging us. So the other Vantage point advantage is that we have integrated security with Active Directory. I try to have that in all of our systems so that we don't have disparate usernames and passwords and everybody starts writing everything down, which is really not that secure. It reduces development costs for our ops reports because right now we're sending everything out to a third party, and it's just enormously expensive to have a developer build something that somebody could just click on as an end user. It pulls live or historical data, allows for trending comparisons with data points from both sites, and it also provides advanced alerting capabilities. So I'll tell you a bit about the different use cases we have. From the operations perspective, I talked a little bit about the pulling the trends across different equipment from different sites. But the other thing is just being able to have these self-service, real-time reports is enormously beneficial. They don't have to sit and send a request to an IT person and wait 5 days to find the information they need. From an engineering perspective, same thing, trending across the sites, but also looking at long-term trend information to understand what needs to change from a process perspective in the plant. And also reporting on these corrected values from within that production accounting system versus the metered values from our HMI. So we understand what the differences are and ensure that we're correcting appropriately. Again, self-service reporting. And marketing, finally, this is a big one for them. They would call the operations control room every time they needed to know what the levels were in the tank before we put this in. You can imagine how much time that took out of the day, not only from within the marketing group, but also the people, the poor guys trying to do their job in the control room. So having this tool allowed them to have direct visibility into the tank levels, which they just loved. They raved about the system the moment it was put in. Very quick win for us. And then in addition to that, we also have alerts going to them. They were the last people to know whenever there was a problem. So if there's a plant outage, unscheduled plant outage, or even scheduled sometimes, they wouldn't know. And they would have trucks coming to pick up oil, and we'd have a lineup back out to the highway of dozens of huge oil tankers with nothing to do because our plant was shut down. So this helps for that. They can reroute those trucks and they can ensure that we're meeting our contractual obligations. This is just an overview of the plant pack system, but we're in the northeast corner on this. What we're talking about is the process information part of their software. Just have a few slides that show kind of what Plant Pack's Vantage Point does. This is the viewpoint part of the software, which just allows you to mimic or show your process control screens through the Vantage Point system. Just an air compressor process, nothing you guys can't see. So this is that marketing report I told you about that they raved over. This is all they needed, and it changed their lives. This is a navigation panel, just allows you to go into the various processes at each of our pads at our Algar plant. Pump run hours, this took somebody 2 seconds to whip up together, but they didn't have this information at their fingertips before. Well pair production, you can see how the well pairs are doing against one another. And I'll just finish off here with a slide about the financial justification for this project. We expect at least a 50% reduction in the yearly operating consulting costs on this customized, the DART system, because we were doing all of our production reporting through there. We still need to use it, but we can probably cut about 50% of the use cases out of that system and put it directly into Vantage Point. Just on that cost alone, we're expecting 2 to 3 years payout. So we've paid for this project in between 2 and 3 years. I'd say it's closer to 2. We're also seeing other costs disappear or reduce. In IT support costs, well, you have a system that users can work on their own. Guess what? My guys are out of a job. But no, we will have far fewer service requests in this area, which allows us to work on other important things. Vastly shortened time to implement new reports. That makes our guys more efficient out in the field, and our engineers head office. And we lower the risk of improper financial reporting. We've standardized our reports. We're locking them down. People can't just tell our management what they want anymore. They have to use the correct source, and it's locked down to only people who understand what data points can be used. And that's it for mine.